Okay, so we are going to be looking at section 18.3, which is special products of binomials. So the first part of the notes actually is just a review. So I'm not going to do that part on the video, but you can go ahead and look at the notes PDF to see what the answers are, and we'll also be going through these in class. So we're going to go ahead and jump right to the lesson, so 18.3. So we'll start off with multiplying a plus b squared. Now, before we get into this, for some people, this section can almost make things more confusing. So I want to make sure we know that what this section is about is actually just teaching you some patterns and shortcuts. Now, for some people, it makes it easier. For some people, it makes it more confusing. But the good thing is you can always go back to how you originally did these types of problems, and I'll go through that in this video. So looking at multiplying a plus b squared. So if we have something like that, this is actually a special pattern. So if we were to multiply out a plus b squared, we would get a squared plus 2ab plus b squared. Now, the reason you'll have that same pattern every time is because you're essentially multiplying a binomial, which is a two-term polynomial by itself. And what this is called is a perfect square trinomial. So what this is we kind of just provided a formula for multiplying a binomial times itself. So we're going to go ahead and use that formula, and then some people will use it and some people won't. So we'll get there. So x plus 4 squared. So when I see that squared, I don't just distribute it. What it means is x plus 4 times itself. So it's really x plus 4 times x plus 4. A lot of people automatically would just say that this is x squared plus 16 just by distributing the exponent, which is incorrect. So what we'll do from here is use our pattern. So if we were to kind of identify our a and our b based on the formula, the a would be the x, so it's like your first term, and your b would be 4, which is the second term. So according to our pattern, it should just be a squared. So a is x, and so it'd be x squared. Then it's plus 2ab, a times b is 4x, and then it's plus b squared. So b squared is 16. So this is really x squared plus 8x plus 16. So we kind of did that without doing our methods of multiplying, meaning distributive property, the FOIL method, or the box method. Now, if that is just making it too confusing and you don't really like it, that's okay. You only need to be able to identify, hey, this is a perfect square trinomial, but you don't really need to know the pattern. So I'm just going to say, or you could just multiply these like how we normally do. So think back to our last lesson. So I'll go ahead and use the distributive property, and I'll kind of change the methods throughout this lesson just so we get a feel for all of them. So x times x is x squared, and then x times 4 would be 4x. Then we'll do 4 times x, which is 4x, and then 4 times 4, which is 16. So you end up getting the same thing, right? X squared plus 8x plus 16, okay? So let's go ahead and take a look at another example. So we have 3x plus 2y squared. So again, what this really means is 3x plus 2y times 3x plus 2y. So if we were to identify our a and our b, our a would be 3x and our b would be 2y. Okay, and according to the formula, it's a squared, so it'd be a squared, then it's plus 2ab, so a is 3x, b is 2y, so when I multiply those together, I get 6xy, and then it's plus b squared, so b is 2y, and then we would square that. So if I were to simplify that, when I have an exponent on the outside, I have to distribute it to both pieces, so this would become 9x squared then plus 12xy plus 2y squared would become 4y squared. That one's a little tricky. Now again, if this is, we're not liking the pattern, it's not for us, then just multiply them. So if we had 3x plus 2y times 3x plus 2y, we could simply do 3x times 3x, which would give us 9x squared. Then we would do 3x times 2y, which would give us 6xy. And then 2y times 3x, which would again give us 6xy. And then 2y times 2y, which would give us 4y squared. So this would be 9x squared plus 12xy plus 4y squared. Okay, so the next problem is multiplying a minus b squared. So a minus b squared. So it looks very similar, right? The other one was just a plus b squared, so this one's just a subtraction sign. So it's going to be very similar formula. So a minus b squared is a squared minus 2ab plus b squared. So once again, this is called a perfect square trinomial. And so it has the same pattern. The only difference is it has a subtraction sign as opposed to an addition sign. So if we were to do x minus 5 squared, I know that that's really x minus 5 times x minus 5. So if I were to identify my a and b, a is your first term, which is x. And I know a lot of us want to say -5, but we're just looking at the actual number. So it would just be 5. So according to the formula, it's a squared. So it'd be x squared. Then it's minus 2a times b. So minus 2, 5 times x. And then plus 5 squared, which is 25. So our answer would be x squared minus 10x plus 25. Okay, again, if we don't like that, if that formula is making it confusing, then just multiply like we did last week. So x minus 5 times x minus 5. If we were to multiply those, let's go ahead and use the box method just to kind of change things up. So if we were to multiply these using the box method, I would have x minus 5 on the top and x minus 5 on the side. So in the first box, it's going to be x times x, which is x squared. Then it's going to be -5 times x, which is -5x, and x times -5, which is -5x, and -5 times -5, which is 25. So it'd be x squared minus 10x plus 25. So you'll see we end up getting the same thing. All right, almost done here. So this is our last type of pattern. So in this one, we have a plus b times a minus b. So they're the opposites. So if we have something like this, when we have a plus b times a minus b, our answer ends up being just a squared minus b squared. This is not called a perfect square trinomial because it's not even a trinomial in the end. So this is actually called a difference of squares. So you have a difference of squares when you have something like x plus 5, x minus 5, 2x plus 1, 2x minus 1. Now, I have to say this pattern out of all of them is probably the most useful because it really is a shortcut. It does cut down your time on solving the problem. So if we have x plus 6 times x minus 6, my a, which is the first term, is x, my b is 6. Now, according to the formula, it's just a squared minus b squared, and that's our answer. So a squared is x squared, and then minus b squared would be 36. So our answer is just that, x squared minus 36. That was super fast, right? Way faster than doing the box. Now, again, if we still don't like it, we could still do the box, or we could still do FOIL. So I'm going to go ahead and do that because it's good practice anyway. So we would have x plus 6, x minus 6. So x squared in this box, it's 6 times x, which is 6x. And this bottom left, it's negative 6 times x, which is negative 6x. And 6 times negative 6, which is negative 36. So we would get x squared, the 6x minus 6x cancel out. So it would just be x squared minus 36, which is what we got before. Okay, our last problem here. So I know that this is a difference of squares again because it's the same binomial. It's just a plus and a minus sign. So on this one, I'm going to go ahead and use the pattern and not use our old method just to save some time here. So I know that our a is our first term, which is x squared, and our b is our second term, which is 2y. According to the formula, the answer is just a squared minus b squared. So a squared is x squared squared, and then minus b squared, which would be minus 2y squared. So x squared squared, you would multiply those exponents, so it's x to the fourth, minus 2y squared, you would square both of those, so it would become 4y squared, and that would be your answer. So again, these are meant to be helpful patterns, but if they are not helpful, then you can go ahead and multiply it the old way.